So we are here. No, we're not. We are here. But before we keep moving on, I want to real quick go to Blackboard and I want to have you not see my password. Now that it's recorded for everybody, it's whatever. And there's a message chat. Why don't you check those? I'm just joking. I put this thing on here, formulas. And if you click on it, it gives a list of all of the questions possible on our exam. I meant what you need on your formula card. So, and I overdid it a little bit. I don't think every single piece is on there, but I thought it's super important to get them anyways. And so this is what you need. So whatever formulas you would need for some of these things, put it on there. Did I not put curvature on here? See, I forgot to put the curvature formula. Ooh. Okay, I get because isn't that the same with the unit tangent, unit normal, and the curvature? All the same. Okay. Sorry, I'm gonna edit. And I'm gonna put curvature right there. Okay. So yeah, sorry about that. Let me also go to the online class so that you're good to go. So because I have to do it twice, it's kind of funny. Um, so, anyways, now you know where to go. Is this a good list? Is this good for you? I mean, y'all understand what I'm getting at, right? Like, and what do you need on your note card? Everything. Correct. Correct. Yeah. So some of these are going to be harder than others. The 3D shapes, obviously, they're easy, but they're hard to put on a note card, right? So whatever little tricks, odd man out, right? That kind of stuff. Maybe you can do like two sheets, two negatives, right? That kind of thing. Whatever tricks that you know, put it on there. Okay. Cool. Good. Now you know. So there's your list. All right, cool. Let's go back and do some more math then. And I'm going to pull up I keep taking it on and off, Chad. Um, this guy here. Okay, cool. Okay. Angle between two vectors. So this one's like super easy, as long as y'all. I mean, if y'all are okay with it. Arc cosine of the dot product, and you can almost just do the dot product just looking at it, right? -20. 1, and 0. Very good. And then my magnitudes would be 17, and this one's a bit trickier. 25 and 5 makes 30? I think so. Now, notice that it says round to nearest whatever. So then that's definitely going to be Desmos stuff, right? Any questions on this kind of thing right now? No, you're okay with this? -20 plus 1 plus 0, square root 17, square root 30. And, okay. They say in radians. Ugh, look. 147 radians. 05? Oh, I can't check it. Nearest hundredth. Am I doing nearest hundredth?
Doing a bit more than that.
Bit more than that. You know, I'm going to leave it. Yeah, 6 is safe. I know. I want to get it wrong. I want to see if they give me it to it wrong or whatever. So give it to me wrong. Are y'all cool with the angle between two vectors? Pretty straightforward. Let's keep cruising. So there's more examples of it. Horizontal vertical components. So this was just sine and cosine, isn't it? So we have our velocity times the cosine of that. Degrees now. Right? Don't let it catch you. Yes, exactly. Exactly. Watch for the circle. I like that.
This is just the basic formula of r cosine theta and then sine theta, or r sine theta.
I guess so.
Okay.
I mean, yeah, I don't see anything I could do otherwise.
Unless there's gravity.
That wouldn't affect your velocity. Yeah. Exactly. So yeah. Yes. Good though. Like this is on there. I mean, everything we look at is on there. It's just I kind of group them and stuff. That this is on there for sure. But did we do this one already? Oh well then. Yeah. We did this one. Okay. Well then I don't know what I was thinking. Okay. Did we do okay? Area of a triangle. I don't know if that's on there, but this is on there for sure. Scrambled. So area of a triangle. I can't remember the formula, but you do. Magnitude. Cross. Okay. Good. Yes. Y'all are both good. Yes. Cross product, magnitude, and then we cut it in two because of the triangle part. Parallelogram would be just the whole, I guess. Okay, good, good. So to do that, we need to pick one of these as our kind of like origin, I guess. I'm going to use R because it's a little easier. So I'm going to go R to P, and I'm going to go R to Q. And so remember, this is terminal minus initial. See, those kind of things are also on there. It's just kind of subtle, terminal minus initial. So I'm going to do P minus R. So there'll be a 1, a -1, and then a -1. And then Q minus R would be a 0, a 0. -1 minus 1 more is a -2. Then I get to cross it. It's conveniently placed. 0 again, -2, and that's a -j component. 0, always a 0, +2, positive I component, and then 0, 0, and always a 0. So 2, -2, 0. And I want the magnitude of that would be, 4 plus 4, square root 8. And then over 2. Thank you. See, I forgot. I already forgot. So what if you put square root 8 as your answer, but the answer is square root 8 divided by 2? You better hope I'm going to add points. If not, you yell at me. Say, hey, Chad, you didn't do that right. I definitely deserve points. Of course I'll add points. I mean, just, you should fight for your grade, for sure. Yes. Yes. Whatever you got here, that's the parallelogram. And then you just cut it in half for the triangle. So again, that's the same formula for parallelogram, right? If they say parallelogram, you already did it. Cool. So which of these is a unit vector perpendicular to the plane? So I think that's just the cross product at all. Like I think that might be this guy right here. Do we have a version that's kind of similar to that? Yeah, C. That's the only one without a K, right? And you could see that, one's negative, one's positive. I might have done something wrong. Oh, 2 negatives right here, look. It doesn't change my answer, but subtle differences, right? Good though. Right, it's the one without a K, and that one looked the best, even when I mess up. Cool. Same thing, copy paste. Parallelograms, the same thing. You choose 3 of these. You don't choose all 4. Right. What I recommend is kind of like mini graphing it and just seeing which ones you want. So here, let's do this. I might not do the whole thing, but I do want to just like preliminarily see where we are. We got -2, 5. So that's somewhere up here. And then it's just rough. 2, 0. So this is A, this is B. We got 8, 2. So like way out here at 2. And then 4, 7 is going to be even higher up here. D. So like, there's your parallelogram. So then you pick whatever you want. I would say like A to D and A to B, basically. I would just ignore C. Or whatever you choose. As long as you make 2 vectors, you're good to go. Say it again. This is A, D, B, and C. So in my case, I would go AD, and I would go AB, and get my two vectors, and then just from there you just roll with it. And I'm just wanting to protograph it just to make sure I'm doing it right. You know, we got 3 hours. 3 hours. I went and looked.
That was for the first exam, it's 2 another 20 minutes, and then on the final you get 180.
I'm being recorded. I can't go and check the settings because you'll see the password. But it's, I thought I put in 3 hours for that.
Look at the syllabus. Is what we looked at.
The syllabus? That's just what we send to other institutions. Yeah, they took it in 2 hours. Fine. If you want 2 hours, I can put that in, but I can make a special case for you. I'm pretty sure I put 3. Yes, I think it's 3. But we'll check after class. But yeah, the idea is, first off, this is a pilot. I have no clue if these tests are good or not. You know, if they're way too easy, good for you. If they're way too hard, then that's bad because I don't want to fail you because of my failure. Does that make sense? I'd always rather go lenient, especially on a pilot where I don't know if these tests are legit yet. We haven't tested them, literally. Cool. You're the test for the test.
I do have one more question.
Yeah, of course.
With this, do we do the cross product of both?
Yes, just like the last one. So then you would cross them and do that magnitude, just like the last one.
This one would be like doing a matrix, right? You just do the cross.
If you want that,
Okay.
that's your call. Yes, everyone's got their own style. Good. This one, I would definitely pick this as my origin. Now, I have no clue where these guys are, but I would definitely go A to something, A to something. That's just same thing, though. Same thing. Same thing. Oh, they give you just 3, so that's easy. Now, again, it's like, man, Chad, how many of these do you have on there? Well, you get 1 on the test, but from a pool of whatever, you know? So, yeah, just be prepared with any of these kind of styles, but obviously they're all the same. This is the same thing. It just has a nice, pretty picture, but it still wants the area, right? Oh, there's a difference here. Look. So there's like these little, these guys. So we got magnitude 4 and 5. Calculate the magnitude of the cross. What? I don't think this is on here, but let's just assume for a second. Is there a formula for that? Is there like a sign? Surely, is there like a... Right. Oh, see, it's covering that up. Yeah, well, that would have helped me. It won't even let me do that. I am attempting it. Look, units, so many units. Oh. Is that what they're screaming about? Okay, goodness, thank you. Man, that was annoying. Thank you. Freaking out. Anyways, so yeah, let's do that. That's the sine, isn't it? Cosine? Now I'm freaked out. Cross product at sine or cosine? Sine? There's the perfect answer right there. It doesn't matter right here. 4 times 5 times square root 2 over 2. Exact answers. Oh, well, obviously we could do this, right? I simplified. Yes. So the area would be half of this. So no. Parallelogram. Parallelogram is the same, isn't it? I don't recall seeing this here. But it's units squared, by the way. I don't remember seeing this, but you never know. Perfect. So yeah, technically, sine. Good, thank you. And so that's good to have it written down just in case, you know. But of theta. Yep, got it. But see how I put in sine of 45 and it's angry at me? So I would definitely stick to the unit circle stuff that you learned so well. Oh wait, didn't help. Unit circle, you learned it for a reason.
Right. I totally haven't used that recall.
Yeah. Oh, that is the same thing. For a parallelogram, it is the magnitude. For a triangle, you cut in half. But they were saying parallelogram. Good, very good. So this one and like the ones coming up are this is like again pooled where you're going to get one of these questions, but they're going to ask different things: distance from a point to a line, a point to a plane, a line to a plane, a plane to a plane, all those kind of things. There's a whole big list of formulas. So just kind of write tiny, I guess. Maybe we can get like a special dispensation in this class for sheets instead of note cards. I'll ask. Okay. So, anyways, there's formulas for these guys. As in, like, I want to pull up the formula for it. I don't want to have to try to break that down myself. So, here. Oh, well, look, we perfectly landed in the right place. So yeah. Point to a line. Boom. And let me just do that, I guess. No, I don't like that. So PS, point to a line that's parallel. Parallel to V. Let me maximize this. Let me think about this for a second. The distance of a point S to a line through P. Oh, that's another point. P point. Parallel to V. This is the slope. Like this right here, this is the slope. Let me write this down. Slope of the line. And these two guys are points. We have a line. There's a point P. There's a point S. Right? But the real distance we want is this thing right here. But this is how the formula would work. It's like a triangle kind of thing. This is super easy. Now that I remember it, we could do this for sure. Can I go back to my doodads? You're copying it down. You good? Okay, I'm gonna go back to what we were doing. This one, and I want this guy. Perfect. So all of those formulas are possibles for getting on there. You'll get one of these. The next one will be point to a plane. The next one's gonna be line to a plane. You know what I mean? You're gonna get one of them. So I need to find a point. So that's my S is the 0, 0, -6, but I need a P point. 0, 0, 0. When you plug in t equals 0, that makes it super easy, right? Yes, I love that. Now my slopes are 2, 2, and 2. And I think we just kind of mush them all together. So that was PS cross V over magnitude of V. Was that it? Perfect. So cross product these things, you can see the PS vector would just be this or with a +6 if you want. It doesn't matter because it'll end up fine in the end. So 2, 2, 2 cross, here we go. So 0 times anything is 0. 0 times anything is 0. 6 times 2 is 12, and this is a positive j. 6 times 2 is 12. This is a negative I, and then a 0. So negative 12, 12, 0. Magnitude of that would be 12 square root of 2, because you're learning all about square roots in Calculus 3. Magnitude of V. Is it square root 12? I was going to do 2 square root of 3. You see the patterns though, right? Yeah, you see. Okay, you're not seeing it. Can I show you? There's 3 2s. Okay. I'm just trying to make it fun because we're here now in calculus. So that would be my answer. It says use radicals as needed. So what, 6 square root 2 over square root 3? And if they don't accept this, I'll be very angry because I don't want to simplify that. What would you get, like square root 6, and then you got a 2 square root 6 essentially? I don't know. Blah, 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 blah. We don't want to do that. Not at this point. Is that okay though? The concept is we need a formula for this. Don't try to derive it during an exam. That would just be insane. The idea is for speed. There's a formula, put it in. And my math lab's good about that. That's one thing for y'all. There's a formula, just pop it in. Any questions? I'm waiting, but we're good. I don't mind waiting as long as I need to wait. Good? Good, good, cool. All right. Distance from a point to a line, same thing. Distance from a point to a plane. Okay, so that's different. Let's go back and find my formula for that. Yes. Yes, I think that's it right there. Plane. So same thing, we have a plane with a normal vector, n. But then there's a point on here, P, and there's a point not on there, S. And again, it's going to triangulate and all that business, whatever it does. Formula, do it. So, same style. So PS dot N over magnitude N. I'm going to rewrite it. I know that y'all are all writing it. I'm going to rewrite it too. Okay, hold on. This guy. And clear this guy out. Reload. Hold on. So we got PS dot N over magnitude of N. Okay. Oh, yeah. Oh, the picture. You like pictures? I love pictures. Oh, yeah, yeah, definitely. And so it'll be something kind of like that. And again, that. I'm gonna redraw it since you know what you can erase. You always use pencil for everything you do. I'm joking. I'm joking. That was the point. That was my point. I was like, you use pencil always, and I know you use colors and stuff. That normal vector is the same kind of direction for this guy. So it's like I'm going parallel to the normal vector, but I need to not have the full distance. I need to find how far that would be. So that's the idea. So yeah, concepts. Go back to what we were doing over on the side. So we have a point, but we need a point on the plane. And I think it's easiest to like plug zeros in and as much as you can. What if I plugged in 0 for y and 0 for z? What would x be? Right. Notice that I didn't want not that one. It's the other one. It's the same formula here, but the other point over here is on that other plane. That's all it is. Just find a point on that second plane, and then just repeat. Well, let's do it. Like on there. No, you can't. It doesn't assure it because you're going to have a triangle that makes it work anyways. So like you're just picking one random point and a random point, and it'll do that automatically. Yeah, but there's probably a thing where you can go 27 minus 12 sine of something, and I bet it's going to work. I'm going to test that later. But let's try this. So I need a point on this one here, and I'm going to go 0, 0, 27. So that's legit, right?
If you want a smaller number, you could also do x as stub in so that you get 20.
I was just going to do.
That's 21.
I was just going to do like 0, 0 something, right? And then I need to terminal minus initial. And so then that would be, because it doesn't matter which direction. Again, what's that number, right? Is 20, sorry, not 20, 15. I know that 15 is part of this thing. N, am I right here? Am I thinking right? So it's 0, 0, 15 dot the 3, 1, 1, but then divided by the square root of this magnitude here. So 9 plus 1 plus 1. So the 15 times the 1 would make 15 in the top over the square root of this thing, 11. So could I, as a formula, take this minus that divided by the magnitude of n, right? See your formula in a way there? I don't know if that'll work every time, but it's definitely worth a shot. Man, I felt, okay, see, and this is, let's talk about it for a second. Now I'm on the spot here, and that's fine. During the exam, right? The concept actually was something simple, right? So it's on me for not looking ahead, but maybe that's a good thing so that you know not to do that. Right? Cool?
So in that formula,
The same formula from the last one.
yeah.
I did the point to a plane, but I just made a second point on that other plane up there. Exactly. And yeah, if they were not parallel, then they would intersect and the distance be 0. So yes, we're a very special case. And that's why my special case formula might just work. Thoughts on that? Maybe. Maybe. But I knew it had something to do with the distance between them, like vertical distance. Okay.
So Chad, the
Go
short
ahead.
way of doing this is just subtracting the 12 from the 27 and
Mhm.
the magnitude
Of n, yeah. That's my thought. I think that is what works. From the slopes, 3, 1, 1. Yep, that's the slopes. Yep. Yeah, the n, exactly. And then we move on to this stuff. So, yeah. Cool. I'm going to delete it from the test. No, I'm not going to delete it now. Now you know. Cool? Cool? Okay, now you know. And it's easy. It's actually easier than the other ones. So shapes and stuff. I mean, if you want me to go back over it, that's fine. But in the end, it's just kind of like, I think y'all should go back through it. And like, there's a bazillion of these questions on the practice quiz. On your exam, I think you get 2 of them. So you'll have 2 of these guys. I don't know if I... Oh yeah, portion just for multiple choice, I know. But like, it is important. So yeah, go back through your tricks and stuff, but in the end, it is multiple choice. One thing I have to say, multiple choice though, I can't give partial credit back on that stuff, at least easily. If you draw something on your blue book, and I mean, you could justify it, then I get that, you know. But when you literally just click A and move on, there's nothing I can do. So, I mean, whatever works, you know. Huh? A proof. Yes, yes. Therefore,
Since we know that an ellipse is x squared over, denominator and y plus y squared over denominator, therefore we can say that this is like a chip shaped thing.
chip shape thing. Yes, that's funny. We were having a discussion. I actually told my algebra folks about hyperbolic paraboloids, and they're like, "What is that?" And I showed them it's like a saddle, and someone said that's like a Pringles chip, and I'm like, "Yeah, but we can't use Pringles because that's copyright, and you can't use chip because it's a crisp." I know that was just. I looked at the can and it says this is not. These are not chips. These are crisps. Okay, whatever. Yeah, Pringles. All right, let's do this again for this stuff. And let's get rid of that stuff so I can get more room. Yay for coding. Don't y'all want to code like me one day? Hack into my math lab? You want to hack into aircraft? Oh, okay. Gosh, man, just memories of 9/11 still. sorry. That might be too fresh. Moving on. So, velocity acceleration. How do I get velocity from this thing? And then this guy would be the. I'm gonna move on. Yeah, this one E. You can take a derivative with E, right? And you can plug in ln2.
Sure.
You're making me nervous.
Right.
Actually, it might work. So the 4 comes down to make a 20, doesn't it? And then I plug in my ln2. ln2. ln2 and E, they cancel and leave a 2. And here, the 4, I think, goes up as the power? Yeah, e to the, okay, e to the ln2. So then these cancel, but you still have this? Oh, nah, yes, hold on. Let me do some log rules. Okay, so we got 20 over 16 e to the 4 times ln of 2. And I need to pop this up as a power first. Like, I'm completely unsimplified, just like you said. So 2 to the 4 power. And then I can cancel them, right? So 2 to the 4, 2, 4, 8, 16. And so that's 20 divided by 16 times 16. Oh, nice. Cool. That's my math lab. Yeah. Happy days for you. Equation for the path of the particle. Oh, right. So yes, x is equal to e to the t, and y is equal to this business here. And then we're trying to compare them, right? I think what we can do here. True, I agree with you. I think I can do a little bit quicker by some power rule stuff there, like logarithmic exponential power rule stuff, and then I can pop that guy in directly, and so then I would get this, and there's your y. But it doesn't work every time, though. You're right. Solve for t, plug it back in. That would be the most recommended way. That was good. Again, second derivative. I'm not worried. Y'all, we're good here. The main thing that was a little weird, but not too bad in the end. Just more of the same stuff. Notice that these are with t's, and then this is plug it in as a 0. Well, you're right, because it's sine and cosine. Notice the format that they have this scalar in the front. I'm gonna be more liberal with that. So just get what you got to get. You know what I mean? Don't. If you get it wrong, I'll look at that. Right. Right. it's annoying. I don't like that. But I mean, I'm not saying that this is correct. But if you had something that looked, something like this and like this, with some numbers in there, I don't know, 25 over 49 or something silly. I mean, it's fine. I'll look at that and see it. I don't want you to get it wrong, but if you don't happen to put it in correctly, that's on them, not you. Right. Sure. Right, right. No, I get you. I'm yeah, I'm trying to be a human when they're not. So, same thing, same thing. I know that looks a little complicated, but it's just derivatives. You can always take a derivative. I don't know if I have any of these on there. I mean, they are hard to see, and even if they are on there, I don't know. I'd have to go back and check. I don't think I put them on there. Too many graphing ones already. I mean, that's legit looking though. Go ahead. Oh yeah, yeah. But this is a pilot. This stuff is on there. 100% sure. Can you take an integral? Sweet. Can you take an integral with sine? What about secant squared? Good. Write that formula down. Because I can't remember it. So yeah, sine squared is my bane. I can never remember sine squared. Oh.
We had to do this a lot last semester.
Yeah.
Take the identity of the sine squared.
As in you took Cal 2 and you had to do sine squared integrals?
Yeah, I think the worst one was secant cube. That was the bane of my existence.
Gross. That's crazy. Yeah. That's crazy. So yeah, any kind of integration things, especially with trig, with powers, right? Because of the things that I don't always remember. Glad y'all do. Difference equations on there for sure. But what do you do with this guy right here? And then you go and solve for C. Do you want me to do it? Sure. All right, great. Now you're putting me on the spot again. Let's find a harder. Let's find a harder one. That one looks way crazier. Yeah. Ooh, let's do both, Chad. So, integrate this in terms of each term there. That's a 1/2 power. So I'm going to add 1 to the power and divide by the new power. I'm just going to do it. So 9/2 just stays in the front. Divide by the new power means it's 3/2. And then this is the new 3/2. Yeah, okay. Don't do what I say. Do what I write. I know. It's terrible. Integrating this guy, you would just get a negative, right? And then this one's the tricky one. Because technically that's... Oh, yeah. You add 1 to the power, divide by new power. But if it's a 0, it's an ln. Good thing there's no chain rule on these guys, right? You're integrating. There is no chain, but there is. It's called U sub. Anyways.
Would that also be
Tangent square root t?
Yeah. Because actually no, that'd be arctangent square root t.
You're thinking this dude. Yeah.
Except for it's square root instead now. Then you get the second power.
Are you joking with me? Okay. I'm so confused. I mean, I'll take it though, I deserve it. Okay, so then we got this guy, which is Happy Days, and it says that this is a K, but what's that number in the front of this K? 1. So it's technically like 001. And that's whenever I plug in a 0, I should get this, right? Because that's like a plus C over there, essentially. If I plug a 0 in here, then I'm going to get that 1, and I get a 3. Okay, so right now I got a 3. Plug in a 0, I get a -1? And then if I plug in a 0, ln of that is a 0. So then this is kind of like my formula right here. I'm saying this plus c equals that. So then my c vector would have to be a -3, a +1, and a 1, right? Am I wrong there? I'm willing to try it. So back to what we're doing. 3t plus 1. Are y'all? Did I make a mistake? Y'all are quiet all of a sudden. We were laughing and having fun until that day. Oh yeah, that's fine. Yeah. Yep. And I might be off by a little bit. What if that's a -1 instead of a +1? You know, I'm gonna. Y'all would add points for mine, right? Okay. Cool. This guy, integral of tangent. Is it secant squared? No. Yeah. Oh. Yeah. Okay. But isn't that the arc tangent? Hold on now. So we got secant squared comes from tangent, right? Derivative of tangent secant squared. Derivative of, this is why we need formulas. not just trying to do this. Secant goes to secant tangent. But then I'd have to create a secant to make it go backwards. So that doesn't make any sense. So there's got to be a formula. I don't have my formula book right now. Y'all are not leaving. Okay, so we'll go grab it. We only got 8 minutes.
Don't worry, I'm going to Google.
Oh man, are you serious? Is that ever going to give you good answers?
I mean, it got me through calculus too, so. By the way.
Oh, ln secant.
Oh, right.
This is the stuff. This is possible. So then that you need to write down. Integral, anything that you're seeing on the practice quiz could be on your exam. So yeah, that was. Oh, you know what? You know how you do this one? You have to do it as sine over cosine. And then you do the u is equal to the cosine. Du then would be a positive sine dx, which we have, right? So this turns into 1 over u du, which is ln of u. And that you put in 1 over cosine. But it said secant. Oh. No. There's something I did wrong here. Yeah. Right. Is it still 1 over? Okay, hold up. Secant. I'm really close. I feel like I'm really close here. Right? Because wait, the derivative of this is ln. Is that how it works? So look, integral of u to the -1. So I'm adding 1 to the power divided by the new power. Yes. Oh, no. We already did the u prime. Why is it secant instead of cosine? I know it's 1 over. Was that supposed to? Oh, yeah. And then I have this guy, du, ln. I don't know. Go look it up. So, man, Chad, you leave me hanging. Yes. Go look it up. Go look it up. I think it says this, so then I would just say that. 2 out of 3 people have said yes. That's what it is. Derivative makes it negative. So it's negative. Pop it up as a power. There it is. And so this is cosine. Sadly, that's not arc cosine. Sorry. There's your secant. You're right. Man, thank you. Right there, I made one little mistake. Better to have a formula than to have to derive that out of nothing, right? Because I was confused. Okay. So look for your practice quiz and be ready. Yes. This one's easier, right? It's 2 derivatives, so 2 integrals essentially, right? But same thing. Ease, we got ease. Ease are no problem. We got time, we got 5 minutes. Projectiles. So if you go back to my big list, I put that down on my big list. Right there, projectile formulas. Just all and every. Whatever you think is best for you. Yeah. Yeah. And sometimes they're not. So whatever you like. If you like those formulas, cool. I'm more of a not formula guy, but it would definitely make it faster. Oh yes, it's a good point. Good point. Yes, exactly. So yeah, there's a thing here. It says it'll take that many seconds to get down the range. My y would then be 0 plus 820 sine of the 60. Okay, Chad, you're just going too sloppy now. Let's start over. 820 sine of the 60, but then also times t, and then it's basically 16 t squared, right? Half of 32. We're talking. Nope. So it's a good thing to write that stuff down too, right? So 1/2 9.8 t squared. What if you make that mistake on your exam? So I would look at it because you wrote it down, right? You're writing your steps down. I'm looking at you, bro. No. Because they gave me that. So you're saying that because I have, okay, hold up. Yeah, that's way easier. Cosine of the 60 times t is equal to 22, and you just take this and divide. Kilometers. And then that's meters. Okay, yeah, you're right. See? How many times would I have gotten this one wrong? Come on. But I wrote it down in nice handwriting. Right? Yeah. That's funny. Let's see if I can get this one at least. Yeah. I'm not trying to pick on you.
What do you keep doing? I'm joking.
I mean, you self-admitted though, didn't you? Did you self-admit that your handwriting was bad?
No, everyone pointed it out.
Oh, my bad. I'm so sorry.
Because I was we were the only ones going up in pre-cal and do stuff on the board. I was down, so everybody just started making fun of my handwriting, even though there's others that are way worse than mine.
True that. True that. Okay. That was a lot easier. Thank you. So yeah, whatever it takes. 16-pound shot. Oh, 6 feet above the ground. There we go. Yeah. Let's. We don't have any more time. So let's come back to this one, and we only got a whole ton left. So, but yeah, we'll just keep cruising next time.